Advanced communication networks. The network topology defines the physical interconnection of its constituent elements. Network topology, mesh topology, star topology, bus topology, ring topology, bus topology. Bus topology is used when a network installation is small. In case of bus network, the various nodes like computer as shown in the figure below are interconnected through a cable. Advantages of bus topology. The bus topology is easy to understand, install and use it for small networks. The cabling cost is less. The bus topology is easy to expand by joining two cables with a BNC by not Neil Consolman connector. Disadvantages of bus topology. Heavy network traffic slows down the bus speed. The BNC connectors for expansion of bus attenuates the signal considerably. A cable break or loose BNC connector causes reflection and brings down the whole network, causing all network activity to stop. Ring topology. In ring topology, each computer is connected to the next computer with the last one connected to the first. Rings are used in high performance networks where large bandwidth is necessary. Advantage of ring topology. No computer can monopolize the network because every computer is given equal access to the token. The sharing of the network allows the network to continue function in a useful manner. Disadvantages of ring topology. Failure of one computer on the ring can affect the whole network. Initial installation cost is high and hence not preferable for low density traffic. If any link breaks or if any repeater fails, then the entire network will be disabled. To install a new repeater for supporting a new device, it is necessary to have the identification of two nearby network. Closed nature of ring topology makes it necessary to remove the circulating packets. Star topology. In a star topology, all computers are connected to a central location where they are all connected by a device called a hub as shown below. Advantages of star topology. As compared to bus topology, it gives far much better performance. Signal do not necessarily get transmitted to all the workstations. In star topology, new nodes can be added or removed easily without affecting the rest of the network. Failure of one node or link does not affect the rest of the network. At the same time, it is easy to detect the failure and troubleshoot it. Disadvantages of star topology. There is a huge dependence on a central hub. If it fails, whole network fails to operate. Many star networks requires a device at the central point to rebroadcast or switch the network traffic. Cabling cost is more since cables are connected to all nodes or computers from central hub. Mesh topology. In case of mesh topology, there is a dedicated point-to-point link from one device to another, as shown. As shown. Mesh topology. In case of mesh topology, there is a dedicated point-to-point link from one device to another, as shown. If there are n nodes, then a fully connected network will have n into n minus 1 physical channels to link devices. The link between the devices in this case are dedicated link, that is traffic is carried out on it between adjacent two devices. If the connections are full duplex, then number of links will be n into n minus 1 by 2. Advantages of mesh topology. The use of dedicated link guarantees that each connection can carry its own data load, thus eliminates traffic problem. In case of mesh topology, failure of one node or computer does not bring down the entire network. It provides security and privacy because every message is sent along the dedicated line. In case of failure, troubleshooting is easy. Disadvantages of mesh topology. Installation reconfiguration of mesh topology is difficult since all node or computers are connected to each other. Node or computer cabling cost is more. The hardware required to connect each link or input or output and cable is expensive. OSM model, Open Systems Interconnections Reference Model, developed in 1984 by the International Standards Organization ISO. It is a way of subdividing a communication systems into smaller parts called layers. A layer is a collection of conceptually similar functions that provide services to layer above it and receives services from the layer below it. Provides a set of design standards for equipment manufacturers so they can communicate with each other. It is basic guideline for protocol development. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. Application layer, presentation layer, session layer, transport layer is called host layers, used whenever a message passes from or to a user. Network data link physical is a media layer, used whenever any message passes through the Host device, physical layer, converts the bit stream through the network all the at the electrical and mechanical level, defines physical means of moving data over network devices, interfaces between network medium and devices, defines optical, electric and mechanical characteristics, voltage levels, timing of voltage changes, physical data rates, transmission distances, and physical connection. Data link layer takes a string of bits and delivers it across a link, conveys the bit stream through the network at the electrical and mechanical level, that is layer 1, turns packets into raw bits and bits into packets, framing and error detection. In data link layer, break the bit stream up into frames, compute an error detection code, transmit each frame separately. In network layer translates logical network address and names to their physical addresses. Example, device name to MAC address, responsible for addressing, determining routes for sending, managing networks problems such as packet switching, data congestion and routing, breaks the data into smaller unit and assembles data, shields higher layers from details of how the data gets to its destination. Transport layer divides streams of data into chunks or segment, reassembles the message from segment, provides acknowledgement of successful transmissions, requests transmission if some segments don't arrive error free, provides flow control and error handling. Session layer establishes, maintain and ends sessions across the network, responsible for name recognition identification so only the designated parties can participate in the session, provides synchronization services by planning checkpoints in the data stream. If session fails, only data after the most recent checkpoint need to be transmitted. Messages who can transmit data at a certain time and for a long time. Presentation translates from application to network format and vice versa. All different formats from all sources are made into a common uniform format that the rest of the OSI can understand. Responsible for protocol conversion, character conversion, data encryption and decryption, expanding graphics commands and data compression. Sets standards for different systems to provide seamless communication from multiple protocol stacks. Application layer, used for applications especially written to run over the network, allow access to the network services that support applications, directly represent the services that directly support user applications. Example, file transfer and email, what the user sees or does. Now protocols, application name was sent NNTP, SIP, SSI, DNS, FTP, Gopher, HTTP, NFS, NTP, SMPP, SMTP, DHCP, SNMP, Telnet, Netconf. Presentation అయితే MIME, XDR, TL, TLS, SSL. The సెషన్లో అయితే నేమ్డ్ పైప్స్, నెట్ బయోస్, SAP, SIP, L2TP, PPTP. The transport layer అయితే TCP, UDP, SCTP, DCCP. నెట్వర్క్ అయితే IPv4, IPv6, ICMP, IPsec, IGMP, IPX, యాపిల్ టాక్. డేటా లింక్ అయితే ATM, SDLC, HDLC, ARP, CSLIP, SLIP, PLIP, IEEE 802.3, ఫ్రేమ్ రిలే, I2ET, G.HN, DLL, PPP, X.25. అది ఫిజికల్ అయితే EIA.EIA232, EIA-EIA449, I2ET, V series, I.430, I.431, POTS, PDH, SONET or SDH, PON, OTN, DSL, IEEE 802.3, IEEE 802.11, IEEE 802.15, IEEE 802.16, IEEE 1394, I2ET, G.HN, PHY, USB, Bluetooth. Switching means is a process to forward packets coming in from one port to a port leading towards the destination. Different switching methods are circuit switching. Circuit switching is most preferred in telephone networks because
switching is a process to forward packets coming in from one port to a port leading towards the destination. Different switching methods are circuit switching. Circuit switching is most preferred in telephone networks. Telephone networks are connected before the actual transfer of information. Circuit switching, there is a physical connection between transmitter and receiver. All the packets use same path, needs an end-to-end path before the data transmission, reverses the entire bandwidth in advance. Charge is based on distance and time but not on traffic. Wastage of bandwidth, it cannot support store and forward transmission, not suitable for handling interactive traffic. Packet switching, no physical path is established between transmitter and receiver. Packet travels independently, no requirement of end-to-end path before transmission, does not reserve the Bandwidth in advance. Charge is based on both number of bytes and connect time. No wastage of bandwidth. It supports store and forward transmission suitable for handling interactive traffic. Flow control. The procedure to be followed by the transmitter, sender, and the receiver for efficient transmission and reception is called as flow control. Stop and wait ARQ. Only one frame at a time on the link equal to poor utilization, that equal to poor efficiency. So efficiency eta equal to T transmit by T transmit plus 2 into T propagation, F by B by F by B plus RTT, 1 by 1 plus 2A. A equal to T propagation by T transmission. It is an example of closed loop control protocol. Positive acknowledgements are numbered in stop and wait. Negative acknowledgements are not numbered. Throughput equal to 1, window or RTT equal to 1, packet or RTT. It is a special category of throughput equal to 1 window bar RTT, that equal to 1 packet bar RTT. It is a special category of SW of window size equal to 1. It is a special category of window of size. It is a special category of SW of window size equal to 1. Go back and GBN ARQ. Receiver window size in brackets RWS equal to 1. Sender window size SWS equal to 2 power K full pakkana minus 1, where K is number of bits received for window size in the header. Efficiency equal to 2 power K pakkana minus 1 into T transmission whole by T transmission plus RTT. T transmission plus RTT అనేది denominator part. WS plus WR less than or equal to ASN, available sequence number. Uses cumulative or piggybacking acknowledgements. GBN is called as conservating protocol. Next, select to repeat SR. WS equal WR equal to N by 2. N means maximum ASN in brackets 2 power K. It uses piggybacking or cumulative or independent acknowledgements. It accepts out of order packets. Efficiency equal to 2 power K minus 1 paina K minus 1 into T transmit, denominator part emo T transmit plus RTT, with piggybacking throughput equal to 2 into packet by RTT. Round trip time RTT, it is minimum acknowledgement waiting time. RTT equal 2 times that of propagation delay. Timeout, it is the maximum acknowledgement waiting time. Addressing refers to the process of assigning unique identifier to entities to achieve communications in between them. Classification of addresses: scope wise, local, global; utility wise, locator, identifier; layer wise, link, network; functionality wise, unicast, multicast, broadcast, anycast. Scope wise classification: this classification is based on scope or geographical extent in which one address is applicable. The addresses are further classified as globally unique addresses and locally unique addresses. Global addresses means that they are applicable through globe. Global other address can't be assigned arbitrarily. They are controlled by a central other. Take example, IP address. A local unique address may be unique within an organization but may not be outside. These addresses are referred to as private address because they used private within an organization. Example, MAC address. Utility wise classification: it is based on utility or purpose that an address serves, and there are two classes of address: locators and identifiers. Locator helps to locate the entity addressed by the locator. The location refers to the geographical location or the topological location. Example, URL. Identifier addresses do not provide any information about the location of the entity being addressed. Ethernet address is one of the example of identifier. An Ethernet address provides no information about the location of a host bearing that address, but uniquely identifies a host machine attached to a network. Layer-wise classification: OSI model follows layer-wise classification. This form of classification results in two broad classes of address: link layer address and network link layer address. Link layer address, also known as the hardware or MAC address, is associated with a network interface card that a network entity uses to attach itself to the network. A network layer addresses refers to addresses that are used by entities to communicate with entities that resides outside. Example, IP address used in network layer. Functionality wise classification: it is based on number of entities being addressed, and we can classify as unicast, multicast, broadcast, and anycast. A unicast address uniquely identifies a particular entity in the network and is used for point-to-point communication. A multicast address refers to an address that identifies a group of unicast address. A packet sent on a multicast address is directed to all entities part of multicast group. A broadcast network is used to forward packet to all entities residing on a network. An anycast address is used when it is desired to reach any number of group out of a group. Here the group is referred to any broadcast group, and the addressing mechanism is called as anycast addressing. The main difference between anycast and multicast is that in case of anycast the packet is sent to only one member, while in multicast it is sent to all the members. IPv4 IP address used for global unique identification. IPv4 version, IPv4, IPv6, IPv4 classful, classless, CIDR అంటాం. ఈ క్లాస్లెస్ CIDRలో రెండు ఉంటాయి. మళ్ళీ సబ్నెట్టింగ్, సూపర్ నెట్టింగ్. సబ్నెట్టింగ్ మళ్ళీ రెండు ఉంటాయి, ఫిక్స్డ్ లెంత్, వేరియబుల్ లెంత్. IPv4 address for flexibility, 32-bit address is divided into 4 chunks, each of 8 bits, so that readability increases. IP addresses has two parts: network ID, host ID. Classful address, identification of classes in decimal notation. Class A means 0 to 127, Class B means 128 to 191, Class C means 192 to 223, Class D means 224 to 239, Class E means 240 to 255. Once again I will repeat. Class A 0 to 127, Class B 128 to 191, Class C 192 to 223, Class D 224 to 239, Class C 240 to 255. Identification of a class in binary notation is done with the help of network identification bit NIB. Class A 0, Class B 10, Class C 110, Class D 1110, Class C 4 ones. Class A 0 unicast 1 to 1 NH dot N dot H dot H dot H dot bar 8. Class B 10 N dot N dot H dot H dot bar 16. Class C 110 N dot N dot N dot H dot H bar 224. Class D 1110 multicast. Class C 4 ones RND. Network ID. All the host bits are made 0. It is address of the network to which host belongs to. Broadcast ID used to broadcast any packet to all machines in the network. All host bits are made 1. Class A number of network bits equal to 7. Number of host bits equal to 24. Number of hosts equal to 2 power 24 పక్కన minus 2. Number of networks equal to 2 power 7 పక్కన minus 2. Having all zeros or all ones either in network ID or host ID is ruled out, and they are meant for special purpose. Class B number of network bits equal to 14. Number of host bits equal to 16. Number of hosts equal to 2 power 16 minus 2. Number of networks equal to 2 power 14. Class C number of network bits equal to 21. Number of host bits equal to 8. Number of hosts equal to 2 power 8 పక్కన minus 2. Number of networks equal to 2 power 21. No special purpose addresses. Loopback address to verify the TCP/IP protocol suite of one machine. It is used for self-connectivity checking. It is also extensively used for inter-process communication. 127.x.x.x X ranges from 0 to 255, but 127.0.0.0 and 127.255.255 not allowed. Default route. If a packet destination address is not known, then if the default route is present in the routing table of the router, then the packet is not discarded but forward to the next router. 0.0.0.0 direct broadcasting. Packets sent to all in remote network. n.255.255.255, n.m.255.255, n.m.n.255. Limited broadcasting. Packet has to be broadcasted within same network. 255.255.255.255. All are 255s. Private address. This IP cannot be routed in the internet but only in an intranet range. First one 10.x.x.x, 172.16.x.x, 2 172.31.x.x, 192.168.x.x. Limitations of logical addressing. No flexibility, no security, not permanent to system. Subnetting. Dividing a network into multiple subnets in subnetting. Bits are borrowed from host ID. It is applicable for single network. Number of ones in subnet mask is always equal to more than network ID bits. Supernetting. Aggregation of 2 or more networks to generate single IP addresses for the group is supernetting. Bits are borrowed from network ID. It is applicable for 2 or more networks. Number of ones always less than network ID bits. It reduces routing table entries. Network IDs of the network must be in sequence. Next, IP data, IPv4 32-bit. It is best effort service and connectionless approach. 22. Next, the IP data header 2260 bytes. Data means bracket lo transport layer header plus data. Header format IPv4 and IPv6. IPv4 అయితే ఫస్ట్ది IPv4 హెడర్ అని వస్తుంది. దాని కింద వెర్షన్ హెచ్ఎల్ టైప్ ఆఫ్ సర్వీస్ టోటల్ లెంత్ అని వస్తుంది, దట్ ఈస్ 4 bytes. నెక్స్ట్ ఏమో ఐడెంటిఫికేషన్ ఫ్లాగ్స్ ఫ్రాగ్మెంట్ ఆఫ్సెట్ అదో 4 bytes వస్తుంది. నెక్స్ట్ టీటీఎల్ ప్రోటోకాల్ హెడర్ చెక్సమ్ అనేది 4 bytes వస్తుంది. నెక్స్ట్ది సోర్స్ ఐపీ 4 bytes. నెక్స్ట్ 4 bytes ఏమో డెస్టినేషన్ ఐపీ. నెక్స్ట్ ఆప్షన్స్ అండ్ ప్యాడింగ్. నెక్స్ట్ డేటా వేరే IPv6లో అయితే ఏమైతే వెర్షన్ ట్రాఫిక్ క్లాస్ ఫ్లో లేబుల్ అనేది 16 byte అది అనమాట. ఇంకా నెక్స్ట్ 16 byte ఏమో పేలోడ్ లెంత్. నెక్స్ట్ హెడర్ హాప్ లిమిట్. నెక్స్ట్ ఏమో 16 byte ఏమో సోర్స్ అడ్రస్. నెక్స్ట్ 16 byte ఏమో డెస్టినేషన్ అడ్రస్. నెక్స్ట్ది డేటా. At source header length is divided by 4 and at destination multiplied by 4. During fragmentation, constant scale factor 8 must be used. Fragments must be divisible by 8 except lost segment. IPv6 128-bit. Internet Protocol version 6 is a new addressing protocol designed to incorporate all the possible requirements of future internet known to us. This protocol, as predecessor IPv4, works on the network layer 3, along with its offerings of an enormous amount of logical address space. This protocol has ample features to address the shortcomings of IPv4. Need for IPv6. Internet has grown exponentially and the address space allowed by the IPv4 is saturating. IPv4 on its own does not provide any security features. Data prioritization in IPv4 is not up to date. IPv4 enabled clients can be configured manually or they need some address configuration mechanism. Features. The successor of IPv4 is not designed to the backward compatible, trying to keep the basic functionalities of IP addressing. IPv6 is redesigned entirely. It offers the following features: larger address space, end-to-end connectivity, auto reconfiguration, faster forwarding and routing, IPsec, no broadcasting, any cache support, mobility, enhanced priority support, smooth transition, ARP address resolution protocol, mapping from logical to physical address. When user knows IP address obtained from the DNS, if the sender is the host or it is found in a routing table, if the sender is router but not the MAC address, ARP request includes a physical and IP address of the sender and the IP address of the receiver is broadcasted, but ARP reply includes the recipient's IP and physical address is unicasted. ARP can be useful if the ARP reply is kept in cache memory for a while, because a system normally sends over several packets to the same destination. An ARP packet is encapsulated directly into a data link frame. An ARP packet is encapsulated in Ethernet frame. Note that the type field indicates that the data carried by the frame or an ARP packet. Cases in which the devices of ARP can be used: the sender is the host and wants to send a packet to another host on the same or another network. The sender is a router that has received a datagram destined for a host on another network. It checks its routing table and finds the IP address to the next router. The sender is router that has received a datagram destined for a host on the same network. RARP, Reverse Address Resolution Protocol, mapping from physical to logical address, finds the logical address for a machine that knows only its physical address present on NIC. The requesting machine must be running a RARP client program. The responding machine must be running a RARP server program. A RARP request is created and broadcast on the local network, and the machine on the local network that knows all the IP addresses will respond with a RARP reply. Problem with RARP broadcasting is done at the data link layer. The physical broadcast address at all once in the case of Ethernet does not pass the boundaries of a network. This means that if an administrator has several networks or several subnets, it needs to assign a RARP server for each network or subnet. User Datagram Protocol UDP. It is connectionless, no acknowledgement and an unreliable approach. It is iterative compared to concurrent TCP. It is used for broadcasting and multicasting. All real-time applications or services utilizes UDP with help of RTP, video conference live telecast, because it has fixed header size. It is message oriented and there is no flow control. Pseudo header consisting source IP, destination IP, protocol used in IP. TCP UDP segment length of UDP is same as TCP. Head format
source port 16, destination port 16, total length 16, checksum option which is 16. ఓకేనా, ఈ సోర్స్ పోర్టు టోటల్ లెంత్ ఇదంతా ఈ రెండు కలిపి 8 బైట్స్ ఉంటుంది అనమాట. ఈ రెండు 8 బైట్స్ ఈచ్. ఓకేనా, నెక్స్ట్ది డేటా application that require bulk data transfer and fastness than reliability uses UDP, transmission control protocol. It is reliable port to port byte by stream transport layer protocol. It supports full duplex connection oriented application that requires bulk data transfer and fastness than reliability uses UDP. Next one is transmission control protocol. It is reliable port to port. Transmission control protocol. It is reliable port to port byte stream a transport layer protocol. It supports full duplex connection oriented cumulative acknowledgement approach. Not useful for broadcasting and multicasting. It is slow start protocol. Uses sliding window protocol for flow control. The window size set controlled by the receiver. TCP connections have 3 phases: connection establishment, data transmission, connection termination. Header format 20 to 60 bytes. First slot లో source port 16, destination port 16, that is 4 byte. Second slot లో sequence number 32, 4 byte. Acknowledgement number 32, 4 byte. Next slot లో header length 4, reversed 6, URG 1, push 1, acknowledgement 1, sync 1, FIN 1, RST 1. Advertised window, that is all 4 bytes. Next slot లో checksum 16, urgent pointer 16, 4 bytes. Next options, next data. TCP uses random initial sequence number. After adjusting all the sequence numbers are repeated. Probability of getting a number equal to 1 by 2 power 32. Protocol which takes services of TCP are HTTP 80, FTP data bracket 20, control bracket 21, telnet bracket 23, SMTP bracket 25, POP3 bracket 110. Dynamic address allocation. DHCP has a second database with a pool of available IP addresses which makes it dynamic. The dynamic aspect of DHCP is needed when a host moves from network to network or is connected and disconnected from a network. DHCP provides temporary IP address for a limited time. The DHCP server issues a lease for a specific time. When the lease expires, the client must either stop using the IP address or renew the lease. The server has the option to agree or disagree with the renewal. If the server disagrees, the client stops using the address. One major problem with the BOOTP protocol is that the BOTP is that the table mapping the IP addresses to physical addresses needs to be manually configured, while DHCP on the other hand allows both manual and automatic configurations. Application layer protocols, domain name systems. It is used to keep track of computers, services, resources both in LAN and WAN environment. It is used to map an URL to an IP address. It uses both TCP as well as UDP services on port 53. It uses 4 servers for applications: root server, top level domain server, authoritative server and local DNS. It offers 4 services: name translation, host aliasing, mail aliasing and load balancing. It uses distributed databases to store information in terms of records. File transfer protocol FTP. It takes services of TCP. Data means 20, control is 21. It has set of status codes and error codes. It has 3 modes of operation: active, passive and extended passive mode. There are 2 modes of access. 2 modes of access means FTP for authority users, username password required. Upload uses TCP. TFTP for anonymous users, username password not required. Download uses EDP on port 69. Hypertext transfer protocol HTTP. It takes services of TCP on port 80. It is a stateless protocol since it does not have any mapping from one transaction onto the other and treats a request and reply as a pair every time. It offers security sockets layer, a protocol for transmitting private documents via internet. It is used to access web pages from www. There are 2 types of connections in HTTP: non-persistence. For every process, the connection is established newly. Persistent and single TCP connection is set on which multiple requests and response can be made. Simple mail transfer protocol SMTP. It uses port 25 on TCP Components of SMTP are user agent UA, mail transfer agent MTA, multi-purpose internet mail extension MIME, mail access protocol MAP, A, POP3, B, internet map IMAP, 4. Cryptography, plain text, the original message before being transformed, and ciphertext after the message is transformed. An encryption algorithm transforms the plain text into ciphertext, while a decryption algorithm transforms the ciphertext back into plain text. Types of cryptography: symmetric key, shared key cryptography under the brackets. Same key or bracketless shared is used by the sender for encryption and the receiver for decryption. Types of symmetric key cryptography: substitution cipher. A substitution cipher substitutes one symbol with another. A, monoalphabetic cipher. B, polyalphabetic cipher. Shift cipher. The simplest monoalphabetic cipher is probably the shift cipher. Transposition ciphers. There is no substitution of characters. Instead, the positions change. In a transposition cipher, the key is a mapping between the position of the symbols in the plain text and the ciphertext. Rotation cipher. Input bits are rotated to the left or right. The rotation cipher can be keyed or keyless. Block ciphers. These ciphers are referred to as block ciphers because they divide the plain text into blocks and use the same key to encrypt and decrypt the blocks. Data encryption standards. DES. The algorithm encrypts a 64-bit plain text block using a 64-bit key. DES has 2 transpositions blocks, P boxes, and the 16 complex round ciphers. They are repeated. The initial and final permutations are keyless, straight permutations that are the inverse of each other. The permutation takes a 64-bit input and permutes them accordingly to predefined values. DES functions is the heart of DES. Advanced Encryption Standard, AES. The initial and final permutations are keyless straight permutations that are the inverse of each other. The permutation takes a 64-bit input and permutes them according to predefined values. DES function is the heart of DES. Advanced Encryption Standard, AES. The Advanced Encryption Standard AES was designed because DES's key was too small. Triple DES increases the key size. The process was too slow. AES is very complex round cipher. AES is designed with 3 key sizes: 128, 192 or 256 bits. Asymmetric key cryptography is nothing but public key cryptography. Asymmetric key cryptography is nothing but public key cryptography. 2 keys, a private key kept by the receiver and a public key announced to the public. RSA, reversed Shamir and Edelman algorithm. RSA algorithm, it uses 2 numbers E and D as the public and private keys. RSA is the public key crypto system that is often used to encrypt and decrypt systematic keys. BOB chooses 2 very large prime numbers P and Q. Remember that a prime number is one that can be divided evenly only by 1 and itself. BOB multiplies the above 2 primes to find n, the modulus for encryption and decryption. In other words, n equal to P into Q. Bob calculates another number phi of n equal to P minus 1 into Q minus 1. Bob chooses a random integer. He then calculates D so that D cross E equal to 1 mod phi. Bob announces E and n to the public. He keeps phi of n and D secret. Although RSA can be used to encrypt and decrypt actual messages, it is very slow if the message is long. RSA therefore is useful for short messages such as a small message digest or systematic key to be used for asymmetric key crypto system. RSA is used in digital signatures and other crypto systems that often need to encrypt a small message without having access to a symmetric key. RSA is also used for authentication. Diffie-Hellman. Diffie-Hellman, on the other hand, was originally designed for key exchange. In Diffie-Hellman crypto system, 2 parties create asymmetric sessions key to exchange data without having to remember or store the key for the future use. The symmetric key for the session is k, g power x mod p whole power y e mod p equal to g power y mod p whole power x mod p equal to g power xy mod p. Problems arise in Diffie-Hellman. Man in the middle attack, it is also known as bucket brigade. Solution: the man in the middle attack can be avoided if Bob and allies first authenticate each other. A, message confidentiality. B, message integrity. C, message authentication. D, message non-repudiation and entity authentication. For a long messages, symmetric key cryptography is much more efficient than asymmetric key cryptography. Message integrity, encryption, decryption provides secrecy or confidentiality but not integrity. SHA, secure hash algorithm. SHA produces a 160-bit digest. SHA-1 secure hash algorithm 1. SHA-1 is a revised version of SHA. each creates a digest of length n from a multiple block message. Each block is 512 bits in length. SHA-1 has a message digest of 160 bits, 5 words each of 32 bits. Message authentication, a hash function guarantees the integrity of a message, guarantees that the message has not been changed. The digest created by a hash function is normally called a modification detection code. MDC, the code can detect any modification in the message. MAC message authentication code. To provide message authentication, we need message authentication code. In MDC uses a keyless hash function. A MAC uses a keyed hash function. A keyed hash function includes the symmetric key between the sender and receiver when creating the digest. If the two MACs are identical, the message has not been modified and the sender of the message is verified. Digital signature. A digital signature uses a pair of asymmetric keys, a public one and a private one. The sender can sign the message digest using receiver's public key, and the receiver can verify the message digest using one's private key. Digital signature can provide message integrity, message authentication, non-repudiation.